Assalamualaikum and good day. My name is Azin Awawi from UTHM, and today I will present to you about the design for machining, but I will only focus on the summary of design guidelines. Okay, and I got it from the Bothroyd Rehearse books. Okay, so there are a couple of categories, and the first one is the category of the standardization. Okay, so one of the guidelines is to use standard components as much as possible because it will save time and save money. Company don't need to buy a lot of things. Okay, standard components for the machining. Okay, one. And the second one is the pre-shape the workpiece by casting, forging, or welding. Okay, for example, you have a car engine and the body of the engine. Okay, for example, car engine. So it is good to pre-shape the body using the casting, and then you're gonna proceed with the machining. So you're gonna save time other than you machine the whole block. Okay, this is one example, one CD example from me. Okay, this is how. Okay, so you're gonna save a lot of time. So you're gonna do less machining and gonna save some time. Okay, and then utilize standard pre-shape workpiece if possible. Okay, so the workpiece. Okay, try to make a design that use the standard pre-shape workpiece, meaning that you do not need to do a lot of machining because the workpiece comes in the same shape, and you can do many things from the same workpiece. Okay, so you just need to buy or maybe just do one set of machining, then you can use to a lot of products. Okay, no product, same as the modular, something like that. Okay, and then employ standard machine features whenever possible. Okay, so the CNC machine, there are a lot of settings, and the standard features is quite common to use. And in your design, try to use the standard features. Okay, don't come up with the something rare or maybe something to lead you to the over engineering. Okay, just do something simple but make the design to be useful and easy to machine. Okay, because if you use the standard procedure or standard tool, you're going to save a lot of time. Okay, the product's going to be simpler to make. Okay, and then about the second category, which is the raw material. Okay, and okay, for the raw material, you should choose the raw materials that would result in minimum component costs. Okay, meaning choose the raw material that costs less but usable. For example, other than using the high price metal, why not using the simple a lower grade metal but still do the work? Okay, okay. Other than using maybe using aluminum, why not try to do something to the design so that you can use plastic, which is cheaper to produce something like that. Okay, okay. Try to use the cheaper raw material in your design. Okay, unless you go for the luxury market. Okay, then what is the other thing? Okay, then utilize raw materials in the standard forms supplied. Okay, because sometimes supplier they in their own catalog they have a lot of type of shape of the material that they can supply. Okay, maybe U shape. Okay, and other things. So to do your design, okay, mesh, try to try to use or try to embed. Okay, the standard form in your design. Do not change the shape to drastically. Okay, just be creative. Okay, use everything that you want that provide by to you, and just arrange in your design. Okay, because if you do this, it will be less time needed for the machining. Okay, and it's gonna be faster to produce. Okay, so the third category is the component design. Okay, component design. So try to design a component that can be machined on one machine tool only. Okay, one machine tool. So no need for two or three setting. Okay, just one. So because to change to other tool, the setup time is, yeah. Although some machine it is not really that long, but it is still time. Okay, so try to help them to reduce the time because maybe you save 20 seconds for a product. Imagine that you're going to produce 1,000 products a day. So you're going to save a lot of time, okay, to the company. Okay, then try to design the component so that machining is not needed. Okay, design not needed on the unexposed surface. Okay, when the component is gripped in the work handling device, so when the thing is gripped, try to design that only the visible surface needed the machine work, but the parts that not really unexposed, no need to be surfaced, no need to be machined. Okay, so they're gonna save a lot. Okay, and then avoid machine features and the company is not equipped to handle, meaning that don't do design that need to be machined by a machine that do not own, the company is not do not own. Okay, machine that is not available by the company. Okay, just do the design that can be fabricated by your company. Okay, don't do something ridiculous, meaning that the company need to send to somewhere else for the fabrication, so it gonna takes money and time. Okay, for the logistics, for the work itself. Okay, try to make something that is available in your company. Okay, and then design the component so that it is sufficiently rigid to withstand the machining force when gripped by the work holding device. Meaning that when you design a component, you gotta clamp that thing to the clamp that thing to the device or work holding device. And make sure that the shape can withstand the force by the machine. Okay, don't make the shape too small, maybe too a funny shape. Okay, I don't know, funny shape. Okay, that is hard to handle. Okay, make something easier to machine and easy to handle. Okay, and then verify that when features are to be machined, the tool, work, holding device would not interfere with one another. So make sure when you do design, the tool, okay, and the holding device and the workpiece will not will not get interfere. Okay, will not crash or something like that. Okay, the sequence, the G code and all those things. Okay, make sure that it's gonna be easy to implement the sequence of machining. Okay, ensure all holes and main bores are cylindrical and the length to diameter ratios are possible to machine using standard tools. Okay, make sure that the holes are cylinder in shape. Okay, do not and avoid that make hole ellipse shape holes, or maybe rectangle shape holes. Okay, or maybe polygon shape hole. That is ridiculous and is expensive to fabricate. And make sure that the tool standard tool can produce the hole. Okay, not the hole that is very small but too deep. Okay, so this one is very hard to make. Okay, so you know be compassionate. Just think of yeah, just use your common sense. Okay, use your common sense. Okay, so end of blind hole. Okay, this is blind hole is the hole that has an ending, not through hole. Okay, end of blind hole should be conical. See, conical shape, conical. And for tap blind hole here, tap. Ensure that the thread does not continue to the end, to the bottom of the hole. Meaning that the tab here, okay, I use the color. So for the tab, here is the tab. Okay, make sure that it does not continue until the end of the hole. Okay, it should stop somewhere before reach this part. Okay, because if it reach this part, it's gonna hard to to fabricate. Okay, and okay, let me show. Okay, so just like before, okay, this one is a through hole, meaning the hole go through. Okay, but for the blind hole, okay, they have some depth to the hole, and make sure that at the end of the hole is conical shape, like this. Don't make it straight, or don't make it quite a circle. No, don't be like that. No, okay, make it conical. Okay, conical. And then avoid bend holes and dog leg holes. Okay, don't make holes that you need to go straight bam and go to this way. This is very hard to do. Okay, this is not this is steel. This is steel. This is not something soft that you can go through like that. Okay, this is not soil. Okay, bend hole. Okay, bend hole like this. Okay, this is bend hole. So avoid this at all costs. Try to avoid. And then dog leg holes is something worse. Something, a hole that you dig by some insects. And okay, so dog leg hole. Okay, don't do this because this is hard to machine. This is not soil, or this is not the oil and gas industry. This is metal. So it is not easy to produce. So try to avoid bend hole and dogleg holes. Okay. So these are reference that this is my reference from the book, and I think you can try to find the books because this is the guy who proposed FMA, and I think that's all for now. Thank you very much.